Have you ever stopped for a moment while filling up your car and wondered what's really going on? I mean, really thought about it. We pull up, swipe a card, stick a nozzle in the tank, and voila, liquid energy flows. It all seems so simple, so mundane. But here's the thing I love. The secret that gets my builder brain buzzing. Beneath that seemingly ordinary patch of concrete lies a world of incredible, hidden engineering. It's a classic case of what you see is absolutely not what you get. It's a carefully constructed system designed to handle a very volatile substance with precision, and most importantly, with safety. So, what's the myth? The myth is that a gas station is just a simple shop with a big tank out back. The reality is far more explosive and far more brilliant. Let me paint you a picture. Imagine a movie scene where a stray spark ignites a trail of gasoline, leading to a massive, fiery explosion at a service station. We've all seen it 100 times, right? It's classic Hollywood drama. Well, I'm here to tell you that in the real world, that scenario is incredibly difficult to pull off. Why? Because the entire system, from the moment a tanker truck arrives to the second the fuel enters your car, is a fortress of clever design. It's an intricate dance of pipes, pumps, vents, and sensors, all working in silent harmony to prevent the very disaster movie makers love to show us. This isn't just about moving liquid, it's about taming a beast. The real magic starts deep underground. We see the pumps, the convenience store, the bright lights. What we don't see are the colossal double-walled tanks buried beneath our feet, holding thousands upon thousands of liters of fuel. These aren't just big steel cans, they are sophisticated containment vessels. Think of them as high-tech submarines for the land, designed to hold their contents securely and to tell us if anything, and I mean anything, is wrong. The sheer scale and complexity of this hidden underground world is the first clue that your local servo is more of a high-tech facility than a simple roadside stop. So, the next time you're standing there, watching the numbers on the pump tick over, I want you to join me in a little thought experiment. Look past the colorful signage and the snack aisle. Instead, try to visualize what's happening right under your shoes. Picture the giant tanks, the network of pipes, and the powerful pumps all humming away. You're standing on top of a carefully engineered machine, a place where physics, chemistry, and clever mechanics come together to make our modern lives possible. It's one of the great unsung heroes of our infrastructure, and it's hiding in plain sight. Let's dive in and see how it all works. The journey of your fuel begins in a place you'll never see, a massive underground storage tank, or UST. These tanks are the heart of the gas station. When a huge tanker truck arrives to make a delivery, it doesn't just pour gasoline into a hole in the ground. The process is incredibly controlled. The truck connects its hoses to specific color-coded ports on the ground, ensuring that diesel doesn't get mixed with premium unleaded. As the new fuel flows into the tank, a special system of vents allows the air and vapor inside the tank to escape safely, preventing a dangerous buildup of pressure. It's a sealed, precise operation from start to finish. Now, how does the fuel get from that giant underground cavern all the way up to the nozzle in your hand? It doesn't just flow by gravity. Deep inside each tank is a powerful machine called a submersible turbine pump. This is the workhorse of the system. When you lift the handle on the dispenser, you're not starting a pump right there beside you. Instead, you're sending an electronic signal down to that submersible pump, telling it to wake up and get to work. This pump pushes the fuel out of the tank and into a complex network of underground pipes, all heading towards the dispensers. These pipes aren't your average plumbing either. They are typically double-walled, which is a fancy way of saying it's a pipe inside another pipe. This is a brilliant safety feature. If the inner pipe, the one carrying the fuel, ever develops a leak, the fuel will be caught by the outer pipe. Special sensors are placed within this outer pipe to detect even the smallest drop of liquid. If a leak is found, the system can shut down the pump immediately, long before any fuel has a chance to escape into the surrounding soil. It's a simple concept with a powerful impact on protecting the environment. Finally, the fuel arrives at the dispenser, the boxy machine we're all familiar with, but even this part is more complex than it looks. Inside, the fuel passes through a meter that measures the exact amount you're getting. This meter is incredibly accurate, calibrated to ensure you get precisely what you pay for. The dispenser also has its own internal valves and a shear valve at its base. This shear valve is a crucial safety device. If a car were to accidentally crash into the pump and knock it over, this valve instantly snaps shut, stopping the flow of fuel and preventing a dangerous spill. It's the final critical step in a long, carefully engineered journey. Safety at a gas station is not an accident. It's the result of layers upon layers of ingenious engineering. One of the biggest dangers is, of course, fire. We all know gasoline is flammable, but it's actually the vapor, not the liquid, that's the main concern. To manage this, gas stations use a vapor recovery system. Have you ever noticed that the nozzle has a rubber boot or a smaller pipe inside the main spout? When you're pumping fuel into your car, that system is actually sucking the gasoline vapors from your tank and sending them back down into the underground storage tank. This prevents harmful fumes from escaping into the air we breathe and dramatically reduces the risk of a fire. Another critical safety feature is constant monitoring. The entire gas station is wired with an army of electronic sensors that act as silent guardians, 24/7. These sensors are in the tanks, in the space between the double-walled pipes, and even in low points around the pump islands. They are constantly checking for leaks, pressure changes, or the presence of liquid where it shouldn't be. All of this information feeds back to a central console, usually inside the store. If any sensor detects a problem, it sounds an alarm, and can even automatically shut down the entire fuel system to prevent a disaster. It's like having a team of tireless robot inspectors on permanent duty. Let's talk about static electricity. That little spark you sometimes get when you touch a car door is more than enough to ignite gasoline fumes. This is why you see those signs warning you to touch your car's metal frame before you start fueling. The pumps themselves are also designed to combat this. The hoses are made with conductive materials, and the entire system is grounded. This means any static charge that might build up is safely channeled away into the earth, preventing a spark from ever happening near the nozzle. It's a simple but profoundly important detail in grand safety. Finally, there's the human element, backed up by technology. Every gas station has emergency. These big red buttons are based on easily accessible. If an employee sees a spill or any other emergency, they can slap these buttons. Hitting it instantly cuts all power to the pumps and stops the flow of fuel everywhere in the site. It's the ultimate manual override, a last line of defense that puts the power to ensure safety in everyone's hands. It's a testament to the belief that the best systems are the ones with built-in foolproof fail-safes. So, after peeling back the layers, we can see that a gas station is so much more than a place to refuel and grab a snack. It's a marvel of fluid dynamics, environmental science, and safety engineering all rolled into one. Every time you pull that handle, you are interacting with a system that has been meticulously designed and refined over decades. It's a system built to handle a dangerous substance with such reliability that we've all come to take it completely for granted. And to me, that is the hallmark of truly great engineering. It works so well that it becomes invisible, seamlessly blending into the background of our daily lives. The beauty of this technology is that it's all about prevention. It's not designed to react to a disaster, but to stop one from ever happening in the first place. The double-walled tanks and pipes, the constant electronic monitoring, the vapor recovery systems, all of these are proactive measures. They are guardians working silently to protect both the customers and the environment. This focus on prevention is what separates a modern gas station from the simple and often dangerous fuel depots of the past. It's a quiet revolution in industrial design that happens right under our noses every single day. Think about the sheer volume of fuel that passes through a single station. We're talking about millions of liters a year, all managed without incident. Achieving that level of performance requires not just good equipment, but a deep understanding of the materials and the physics involved. From preventing the buildup of static electricity to ensuring that every liter is precisely measured, every single detail has been considered, tested, and perfected. It's this obsessive attention to detail that I find so fascinating. It's the kind of problem solving that pushes technology forward in ways we often don't even notice. So, I challenge you. The next time you visit a gas station, take a moment to appreciate the hidden genius at play. Look at the nozzle and remember the vapor recovery system. Glance at the ground and imagine the fortress of tanks and sensors beneath you. Think about the silent pumps and the network of pipes that bring that energy to your vehicle. You're not just at a roadside stop. You are standing in the middle of a sophisticated, high-tech facility. These places aren't just fueling our cars. They are incredible examples of everyday engineering excellence, hiding in plain sight. And that's no myth.